Hey, if you're watching this, you probably clicked on this link right here, how to do chapter 6.1 notes. When you click on that link, you're going to need to open up a new Google Doc. All right, you probably want to put the title is chapter 6, notes, ESS, something like that. All right. Mine look like this, chapter 6 notes, atmospheric systems and societies, because that's the title. Down here, I'm going to move this. Introduction to the atmosphere. Atmosphere is dynamic, it's never static. So here's the deal about the atmosphere. It's never like one thing for millions of years. Even if humans didn't exist, it would still be going up and down and all around. It did when the dinosaurs were around, it did even before the dinosaurs. So the atmosphere affects all ecosystems in different ways too. I mean, here in Connecticut, we've got a river valley where it's hot and humid. So we have a lot of water vapor in our atmosphere. If you go way off to the Rockies, where it's way up in the mountains, the air has a lot less oxygen in it. Also, is that much closer to the sun, so it gets more solar radiation. Albedo. You might need to pause this video. You might need to go take a look and get a definition for that. ALBEDO. Yeah. No, sorry. ALBEDO. Okay. Now, these ones in yellow down here, after you get the definition for albedo, I'd love for you to look these up. The orange too. Down here, what's the oxygen composition at high altitudes? Yeah, I'd love to. I kind of gave you that one away with the Rocky Mountains. What's the air like in the jungle? I mean, what's the humidity level like? What's the air in the desert like during the day? What's the air in the desert like during night? What type of atmosphere do plants generally like? Do they like it kind of dry? Do they like it hot and humid? And also, what's your thoughts on greenhouse gases? Good, bad? You know, tell me, hook me up. For this one right up here, let me see what I got here. Yeah, don't throw down the chat, throw down in your notes. Atmosphere. It's mostly made of nitrogen and oxygen, small amounts of carbon dioxide, argon, water vapor, and trace amounts of other gases. So, everyone, we always make a big deal about the carbon dioxide, but we have a lot of nitrogen and oxygen, and there's just the carbon dioxide has such a big effect. Humanity messes up the input and output of these gases big time. It's look, when we cut down a tree that, or like a forest, that takes away photosynthesis abilities. When that takes away photosynthesis abilities, that really messes up with our oxygen and carbon cycle. Also, too, when you're burning fossil fuels for a car, that's affecting the carbon dioxide and how much carbon dioxide we put out. Over time, the atmosphere has changed naturally and unnaturally. So again, if humans weren't around, we would still be having these issues with the atmosphere. Not to the degree that we are, though. All right. Atmosphere is from the ground to 1,100 kilometers above, sea level. And there's several layers, but the important ones are the troposphere and the stratosphere. Troposphere is from the ground to about 10 kilometers, and the stratosphere is 10 kilometers up to, I think it's about 50 kilometers. Yeah, good. Memory isn't too bad. So that's what we got for so far. There's abiotic factors that affect the atmosphere. Temperature plus precipitation. So the warmer it is, the more heat there is for those carbon atoms, and also to your greenhouse gases to hold on and trap the heat with radiation. Precipitation. That is another one. Precipitation can bring carbon back down to the earth, help out with that. Here's the problem, though. In the past, we can't measure the amount of precipitation there was. Just hasn't really been a really way we've come up with. You can sort of measure the temperature. It's measuring off of like sediment on seashells and old fossilized sea creatures. not sure how accurate that is. I have my doubts. You can measure the atmospheric gas concentrations real easy, though. If you remember in 10th grade when we were talking about the Vostok ice core, where they drilled down like with a straw into the ice in the Arctic, and they went and they took out the ice and then took it out and they melted it and they measured the amount of gas that there was in there. So we could tell like the gas concentrations of the atmosphere way back. So biotic factors, which are living factors, are plants and animals. We're having a lot more animals in this world because a lot more humans. Plants too, we're having less plants because of how we're kind of handling our resources. Free oxygen. You're going to have to get a definition for this one. Feel free to, I'd put in like look at Google if you want, but then put it in your own words. Before plants, photosynthesis, there was none. So we didn't have any free oxygen in the atmosphere until we had plants, for real. So photosynthesis is the process with plants where it converts, and produces oxygen. So plants are kind of necessary for our atmosphere. You're gonna have to create a table for this. 3 across, 4 down. This shows the time, temperature, carbon dioxide parts per million. Time, 300, we're gonna put in here millions of years. Oh. So this one here is 350 million years ago. The temperature was 20 degrees Celsius, and there was 1,500 parts per million carbon dioxide. Atmosphere is mostly carbon dioxide. Then plants came around. Hey, 300 million years ago. Temperature drops like my mixtape, down to 12 degrees. All right. What happens to the carbon dioxide? That drops too, down to 350. Now, we ain't at 350 anymore, though. We're at more like 400 presently today, and the average temperature is 15 degrees Celsius. So we can see the carbon dioxide rising, and we can see what happens with the temperature. We just don't want to get back to this because that would be bad. Yep. Everybody be living, well, wouldn't be living. So for this pink part here, you're probably going to have to pause the video again. I want you to understand radiation and convection. Just put something down, an example, something that works for you. A definition if you really want. Just so you understand it hardcore. Greenhouses work by reducing the amount of convection. All right, big thing. All right. They reduce the amount of convection, which is in heat loss. Our atmosphere works by increasing the amount of radiation. So it works almost like a blanket to insulate you. Our atmosphere doesn't produce heat, it just radiates it, traps it, radiates it. Most incoming solar radiation is bounced back before hitting Earth. Yeah, so it comes in, it hits a cloud, it hits gas particles, and it goes bing, and it goes back out into outer space. The solar radiation that does hit Earth is absorbed and gives back as infrared energy, heat energy. So yeah, it comes down during the day, it hits the blacktop, and then the blacktop is like, oh, heats up warm, and at nighttime it's like just lets that heat go. It's not just blacktop too, it's trees, everything does it. Some more than others. Let's see what it's got here. The greenhouse gas is trapped. That stuff to keep. Greenhouse gases trap that stuff to keep the heat in. So yeah, the greenhouse gases are big on trapping in this infrared heat energy. Lots of gases that do this, but water vapor, carbon dioxide, methane are the biggies. So you know this if you're living in like the summertime, if you're by the Connecticut River, if you're like it's really kind of swampy. It's just that you're breathing in, it's not dry air. It's very it's very humid. A lot of that's that water vapor, and that water vapor just traps in heat. So even like when the sun goes down at like 8 o'clock at night, 9 o'clock tonight, it still is swampy. All right, just hot. Plants love that, by the way. But it does trap in heat. Carbon dioxide. Carbon dioxide also traps in heat. That's the one that's like off of cars and stuff. A lot of fossil fuels being burned. Methane, cow farts. All right. Other sources of methane too. Methane holds on to heat extremely well. All right. Yeah, and that's what we got so far. Okay. Once you're done with this, I'm gonna try hooking you up with some questions, and they'll just be on our test. So, yep.